Hello everyone, I am going to present the impact of the new management of waste containing norm on concerned workers. I am going to introduce briefly the context in France for the new management of waste containing norm, and then I am going to present the type of waste and the considered workers with their exposure pathways. Finally, I am going to continue with the results and the sensitivity studies to conclude with a recommendation for landfill operators and relevant authorities. Following the example of other member states of the European Community, France must transpose into its national law the European Directive 2013-59 Euratom, which emphasizes the importance of the management of industries involving norm and the waste generated by these industries. In France, there is also the problem of the volume of waste containing norm to be stored. This waste is mostly very low-level waste, but the volume is very large, and the radioactive waste storages in France are not sized to store all this waste containing norm, in addition to the other very low-level waste from nuclear activities. That's why the authorities have decided to adopt the following graded approach. The waste containing norm with an activity concentration below 1 becquerel per gram can be stored in any type of unconventional landfill. It is said inert or non-hazardous or hazardous waste landfill. The waste containing norm with an activity concentration between 1 becquerel per gram and 20 becquerel per gram can be stored in non-hazardous or hazardous waste landfill with radiological survey. The waste containing norm with an activity concentration above 20 becquerel per gram must be stored in a dedicated radioactive waste. Due to the diversity of the industrial sectors involving norm as well as the industrial processes for the same sector, waste containing norm is very varied and has different characteristics such as its physical and radiological nature. Indeed, the waste may be in solid or in past or in powder form, and in the same way, it can contain only radionuclides of the uranium chain or the thorium chain, or a mixture of this both. The density may be higher or lower than 1, depending on the physical nature of the waste. And finally, the waste may be conditioned in different form like big bags or tanker. This point has an importance for the workers' exposure, as I will show you later. So for this study, 3 following waste are retained: a rich uranium waste, which contains only radionuclides of uranium chain and potassium-40, rich thorium waste containing only radionuclides of thorium chain and potassium-40, and mixed waste. For each type of waste, it is assumed that the activity concentration are equal to the regulatory limits to be stored in a non-hazardous or hazardous waste landfill. It is also assumed that the circular equilibrium is established and that the waste is conditioned in big bags. Each type of waste are considered in the past in the powder forms. The concerned workers are the truck driver who loads, transports and unloads waste, and the landfill worker who realizes all the tasks in the landfill, like control before reception, waste unloading, installation of waste in the storage cells, etc. For these two workers, the exposure pathway are the external exposure, the internal exposure by inhalation, and by inadvertent ingestion. It is assumed that the worker do not wear any personal protective equipment like gloves or mask. In an outdoor atmosphere, the radon exposure is generally negligible. This can be verified by calculation or measurements. This exposure pathway is therefore not considered in this study, but it remains an exposure pathway to the operator of landfill should not neglect. The skin exposure is not considered in the effective dose. That's why it is not presented in this presentation, but it should be considered by the landfill operator. For the external exposure, it is very important to identify all the radiation sources and to describe them with their geometry, the distance between them and the workers, and the exposure time to each source. To assess the exposure pathway, calculation tools like microshield or Mercurad are used. As for the external exposure, it is important to well identify each source of dust and the exposure time to them for assess the internal exposure by inhalation. For each source of dust, the assessor has to estimate the dust levels. For instance, a dust level of 0.1 milligram per cubic meter is written for waste in past form, and dust level of 10 milligram per cubic meter and 0.1 milligram per cubic meter are written for waste in powder form, depending on the task realized by the workers. The assessor has to choose an inhalation rate and a relevant dose coefficient. The exposure by inadvertent ingestion is assessed with the model hand-to-mouth contact. So the assessor has to define the contact time to deposits over the hands to each relevant sources, the transfer factor by hand-to-mouth contact, and the frequency of this contact. One of the most important parameters is the quantity deposited over the hands, and it can depend on the physical nature of the waste. So for the driver, the effective dose varies from 3 millisievert per year to 17 millisievert per year, depending on the radiological characteristic and the physical nature of the waste. For the landfill worker, the effective dose varies from 5 millisievert per year to 18 millisievert per year, depending on the radiological characteristic and the physical nature of the waste. Whether for the truck driver or the landfill worker, they have to be considered as exposed. However, the effective dose does not exceed the regulatory limit of 20 millisievert per year. As example, this figure shows for the landfill worker the distribution of exposure pathways according to the physical nature of the waste. So the physical nature, especially the dust level and the ingested quantity, are very important hypotheses for the assessment of the effective dose. Indeed, their values have a significant impact on the distribution of the exposure pathway and on the effective dose. This figure shows the importance of the dust level considered in the study to assess the effective dose. And this one shows how the ingested quantity of waste and dust impacts the effective dose. Another parameter which has importance for waste in powder form is the conditioning for transport. Indeed, this type of waste can be conditioned in big bags or can be transported in bulk in a tanker. In this last case, the geometry of sources, the exposure time, and the dust level during the different tasks for the truck driver and for the landfill worker are different than the values for a packaging in big bags. The effective doses are a little lower for a transport in bulk in a tanker than for a packaging in big bags. Furthermore, the operator has to take into account degraded operating situations like the breakage or fall of big bag, the sleeve breakage during zero tank transfer, or the overflow of powdered waste. For each of these situations, the impacted hypotheses are dust level and exposure time. It is important to estimate the frequency of the degraded situation and how to prevent them and define procedure in the event that such situation arises. So the recommendations for the landfill operators are to ensure that the radiological characteristics of the waste-containing norm are respected, to optimize ventilation and hygienic requirements to prevent or limit the dust level and inadvertent ingestion, to wear mask and gloves if the previous provisions are not sufficient, to well identify the degraded situation with all relevant procedures to prevent or to resolve them, and to well inform and train the workers. The recommendation for the relevant authorities is to control during inspections that the radiological characteristics of waste are respected and that the specific provisions put in place by the operator are relevant and sufficient. Thank you for your attention.